Okay, this is McGraw-Hill Chapter 5, Section 7, Applications of Variation. Okay, all right, this deals with three types of variation. You have direct variation, which is y equals kx. K is always the constant of variation. And basically what we have to do is we have to find k first, and then what they'll do is give us one of y or x to find the other. The inverse variation is y equals k over x. So in direct variation, when y increases, x increases. When y decreases, x decreases. In inverse variation, when y increases, x decreases. When y decreases, x increases. And then you have joint variation, which is really a combination of the two of them, or two direct variations, two inverse, direct and inverse. It's just where these two come together in one problem. If we look at example 1, the first statement says the circumference of a circle varies directly as the radius. Notice that they have to use the word directly or inverse, so it makes it pretty easy. So if we make circumference C, and we make radius R, and it varies directly, and what happened is the formula becomes C equals KR. Circumference varies directly with R. Go to letter B, it tells us at a constant temperature, the volume of a gas varies inversely with pressure. So volume inversely pressure. So we come over here, and we have V for volume, inverse P on the bottom, K on top, inversely. And the last one says the length of time of a meeting is directly proportional to the square of the number of people. So if we let T be time, it's direct, and N be number of people, we have T equals K N squared. We talk about joint variation. Here's a couple of joint variation problems. This is example 2 on page 475. It says y varies jointly as u and the square of v. So y jointly, meaning direct, u v squared. So that's what we have here. Y equals k u square root of v. Square root of v. Okay. And the last one here says gravitational force of attraction between two planets varies jointly as the product of their masses, which means directly, and inversely as the square of the distance between them. So force, K on top, remember K is always in the numerator's place, times the product of their masses, mass 1, mass 2, over the square of their distances. Okay? Now here's the type of problems you're going to have to deal with in terms of the type of problems I'm going to give you on a test. All right, this one here says the speed of a race, this is example 4, speed of a racing canoe in still water varies directly as the square root of the length of the canoe. So our formula becomes speed S equals K, our constant of variation, times the square root of L, because it's a direct variation. Go to part A, and it says if a 16-foot canoe can travel 6.2 miles per hour in still water, find a variation model, meaning an equation, that relates the speed of a canoe and its length. So if the speed was 6.2, we're going to put it in for speed. If the length were 16, we're putting it in for square root. Square root of 16 is 4. Now notice I switched sides. So I have 4k equals 6.2. All I did was take the square root of 16, get 4, put 4k on this side, 6.2 on this side. Divide by 4 and we get k is 1.55. That means we take 1.55 and substitute in for K in the original equation. Now we go to part B, and it says, find the speed of a 25-foot canoe. Well, 25 is the length, so we're going to put it in for 25. Take the square root of 25, which is 5. 5 times 0.15 gives us a speed of 7.75 miles per hour. So in these type of problems, you're going to get information. First of all, it's going to give you information to get either direct or inverse variation. I'm not going to give you joint. Then it's going to give you information to find numbers where you can find your constant variation. Then you take your constant variation and substitute it back in the formula. They're going to give you one of your two variables and you have to find the other. In inverse variation, here's an inverse variation problem. It says the loudness of sound measured in decibels varies inversely as the square of the distance between the listener and the source of the sound. So we lay LB loudness, this equals K over D squared, distance squared. And remember, it said inverse, so we know we're having K on the top and our second variable on the bottom. And make sure you notice the first variable mentioned is always the one that is by itself. The second variable mentioned is always the one with K. So if we read further, it says if the loudness of sound is 17.92, that goes for L, at a distance of 10 feet, that goes for D, from a stereo speaker, what is the decibel level 20 feet from the speaker? So what we've got to do is we've got to use the 17.92 and the 10 feet first to get K, which is what I've done here. Put 17.92 in for L, 10 in for D. 10 squared is 100. Multiply 100 over, and we get K equals 1,792. We're going to take that 1,792, put it in for K in the formula. Now we have L equals 1,792 over D squared. Then all I have to do is take the information it gave me, a 20-foot canoe. Put 20 in there, square it, I get 400. And if I take 1792 and divide by 400, I get 4.48. That's all there is to it.